Dear students, we said that we have three different ways for heat transfer in conduction, convection, and radiation. In conduction, that's both particles with a different temperature are in contact. We have two different type of materials. The first one that can transfer thermal energy very well. So substances that can transfer thermal energy very well are called conductors. And substances that cannot transfer thermal energy very well are called insulators. So substances that can transfer thermal energy very well are called conductors, and substances that cannot transfer thermal energy very well are called insulators. We have some examples. For example, in the previous video I said, for example, if the doctor put the stethoscope on your back, you feel cold. Why? Because the material of stethoscope, it is conductor. So, but when the doctor put the wooden compressor on your tongue, did you feel any cold material on your tongue? No. Why? Because there is a different material with a different mechanism of the transferring energy. For example, the thermal energy inside your skin can transfer to the stethoscope very well because the stethoscope is conductor. So we have a lot of examples of conductor that's made up of metals. For example, the iron coil, iron coil, or the curl iron, or silver, copper pipe. And example of insulator, as I said, is for example, something is made up of wood, something is made up of foam, and for example, the ceramic and clothes, cotton, plastic. So those objects are made up of materials that can't transfer thermal energy very well, and they are called insulator. But the materials or substance that can transfer thermal energy very well are called conductor, and they are mostly metals. About the radiation, we have a phenomenon of the earth which is called the greenhouse effect. Greenhouse effect, as we know, that the earth has atmosphere. So this atmospheric layer, the sunlight, can pass through this atmosphere and heat the earth. But also the atmosphere and the greenhouse gases inside the atmosphere, like water vapor and like the carbon dioxide, can absorb some of the lights that comes from the sun. So we said the light can penetrate or the atmosphere and can hit the land of the earth, and some of the lights can be reflected by the earth. During reflection of this light, the greenhouse gases like water vapor, carbon dioxide, nitrous oxide inside the atmosphere can absorb this light that's reflected by the sun and re-radiate to the earth. By this way, the earth keeps its temperature for a life. So if there is no greenhouse effect or there is no greenhouse gases around the earth will be lifeless and it will become cold planet. But because of the greenhouse gases, the earth can keep its own temperature by re-radiate the light that's reflected by the earth. But unfortunately, during increasing the vehicle exhaust and the factories and the gases and carbon dioxide and other gases that's produced by the car and vehicles to the air, increase the amount of water vapor, carbon dioxide and other greenhouse gases in the atmosphere, and by this way the earth become warmer and it's produce deforestation on the earth's surface. So after that, after explaining the ways of heat transferring, we have to know the term which is called specific heat. And specific heat is amount of energy that's needed to increase the temperature 1 kilogram of mass by 1 degree Celsius in the constant pressure. So before explanation of specific heat, maybe you have noticed that in a swimming pool, maybe you notice that the temperature of the water is less than the temperature of the air which is around the swimming pool. So the water is colder than the air. We have to know why this one is happening. So specific heat, what's specific heat? For explanation of specific heat, we have to know that it's amount of energy that's needed for increase a temperature of 1 kilogram mass by 1 degree Celsius in a specific pressure. So each type of material has its own specific heat, and we have a table inside your book which is it is a type of material with their specific heats, but it's not for memorizing. We have to give you the specific heat of materials inside the questions if you want to find the specific heat of each materials or heat transferring. So we said that specific heat, it is amount of energy that's needed for increasing the temperature of 1 kilogram of substance by 1 degree Celsius. So after that, we said that there are a different kind of materials with a different kind of specific heat. And we said, for example, the sunlight can heat the earth, and both air and water can take the thermal energy from the sunlight. But the air is warmer than the water. Why? Because the water specific heat is more than the air specific heat. So by this way, the air can increase temperature easily than the water. So it means the amount of transferring thermal energy to the air is more than the amount of energy that's transferred to water. So because of that, we have a specific equation for specific heat or heat transferring that said that heat is equal to the specific heat of material multiplied by mass and multiplied by changing in temperature. For example, if we have a cup of water, I said that I'm not good in drawing, especially in this side. We have a cup of water, which you put under the sunlight, and sunlight can heat it. So the temperature of it is 25. hour, it's changed to, for example, change to 80 degrees Celsius. But it's not under sunlight, probably it's maybe on the stove or, okay. So the amount of water here is 0.2 kilogram. And we have to know the specific temperature of the water, which is the specific temperature of water is 4,184. So 4,184. This one is the specific temperature of water. So we have to give those information inside the question, and you can put it inside the equation for identify the heat that's transferred for this water. So the specific heat is 4 multiplied by mass, which is 0.2, and the unit of specific heat is joule over kilogram degrees Celsius multiplied by mass 0.2 kilogram and multiplied by changing in temperature. Changing in temperature is the last temperature minus first temperature. So 4,184 joule over kilogram degrees Celsius multiply 0.2 kilogram multiply 80 minus 25. So it is equal this degree Celsius can cancel this one and this kilogram with this one, and we have to multiply this numbers, these numbers, that's maybe 4.6 thousand and blah blah blah, and the unit is joule. Okay, so the kilogram cancel kilogram and the degree Celsius cancel degree Celsius, and the unit of heat we said, and the transferring of thermal energy is joule. And we have a section review, which is page 233. You have to read the sum up of this section, and please solve all the questions inside section review, which is page 233, and the chapter review, which is page 234 and 235. It's your homework, and please read all the question and answer all the question inside section review and chapter review. Have a nice day. Thank you.